Lesson 5 and 6 of Course 3. We're going to look at both of these, but first, Lesson 5 is all about fractional parts. The goal is to be able to compare and order fractions. And today, we're just looking at fractions that have the same numerator, but different denominators. And the two parts of our fractions, remember, first on the top, we have our numerator. On the bottom, we have the denominator. The denominator cuts something up into a certain amount of parts, and the numerator tells me how many of those parts I have. Let's come back to this in just a minute. Let's first compare and order some fractions. So if we have 3/6, 3/5, and 3/8, well, if that denominator tells us how much it's being cut up into, the larger the denominator, actually the smaller we have. So 3/8 is actually going to be our smallest. Because if we were to take a pizza or something, cut it up into 8 pieces, and I only get 3, that would be smaller than cutting the same pizza into 6 pieces and I get 3. Okay? So our next one is actually going to be 3/6, and our last one is 3/5. Okay? So the larger the denominator, the smaller the piece I have. Similarly, with our hours, 2/3 of an hour, 2/5 of an hour, our 2/3 is greater than 2/5. Now we can confirm this by figuring out how much of an hour I have in minutes. So I could say, well, an hour is 60 minutes, so 2/3 of 60 minutes, well, that's 40 minutes. And I could do the same with 2/5. 2/5 of 60 minutes. Well, that's just 24 minutes. And we can see that we do have 40 minutes being greater than 24 minutes. Now let's do an example where in this one actually we have some different denominators, but we still need to be able to compare them. So let's say you have a test coming up and your teacher says there are 30 questions on the test, 1/3 are true false, 2/5 are multiple choice, and the rest of them are going to be short answer. We need to know how many questions were true false, how many were multiple choice, and how many are going to be those short answer questions. So if we take the true false, that means that we have 1/3 of the questions. Well, the entire test is going to be 30. So I have 1/3 of 30 questions. Well, of in math means multiplication, so I'm going to multiply. Now right now I have a fraction times a whole number, so to be able to multiply these, I need them both to be fractions. So I turn 30 into a fraction by just putting it over 1. That doesn't change the value, but it does put it in fraction form so that I can multiply across the top to get 30 and multiply across the denominators to get 3. And I see that I get 10 questions. Now, how about multiple choice? Same idea. We still have the original 30 questions. I'll put it over 1 right away. And we have 2/5 of them being multiple choice. Well, I can multiply across the top. I can multiply across the bottom. And we can see 60 divided by 5 is 12 questions will be multiple choice. Lastly, we need to know how many were neither or short answer. There's a couple ways to do this. One is looking at how many questions were true, false, how many questions were multiple choice, and we know we need to get a total of 30, so we could say 10 plus 12 is equal to 22. Well, that means that 30, our original total, minus how many we had for the other ones, gives me how many are left for the short answer. So we have 8 questions. Now, even if we didn't know how many questions were on the test, we could figure out what fraction of the test was going to be short answer by just looking at the fractions and saying, if I have 1/3 is the true false and 2/5 are the multiple choice, I can add those together to figure out what I have in total for those 2 types of questions. But to add fractions that have different denominators, I need to get common denominators. And we can see, well, 3 and 5 have 15 in common as a multiple. So to get there, I need to take this 1/3 and multiply 5 over 5. Not changing the value by doing that because I'm really just multiplying by 1, but now I can get a common denominator. And for the 2/5, I can multiply by 3 over 3. So I get 6/15. Altogether, with those two types of questions, I have 11/15, which means that if 15 over 15 is one whole test, there are 4/15 left for the short answer. So 8 questions, but in fractional form, that means that I have 4/15 of the test being short answer. So fractional parts, look at those denominators to see how much is being cut up and go from there. The next part of this is lesson number 6, converting measures. Now I'm going to show you a system of how to do this that will work with any type of converting measures and will actually set you up for a lot of success in the future if you do it this way. So your goal is to be able to convert units of measure both with metric and with the U.S. customary system. So if you're looking at the Saxon Course 3 book, we have this on page 37, a really great chart of different equivalent measures. We are going to need to use this chart to be able to convert some measures. And our first question says, how many milliliters are there in 2 liters? So I have 2 liters, maybe a 2-liter soda. And I want to convert that to have a final answer of a certain amount of milliliters. Well, whenever I look at these problems, I'm going to take what I know, so 2 liters, and I'm going to put it as a fraction over 1. Because I am going to use one of these measures in this chart to convert liters to milliliters. And from what we know about fractions, if I multiply by something that is equivalent top and bottom, numerator, denominator, I'm not changing anything, but I am helping myself get to my goal. All right? By multiplying by 1, we're allowed to do that with fractions. So if I look at my list, I can see that I have a conversion right here of milliliters to liters. So I want to put that in fraction form. I can be smart about this by looking at, I want to get rid of liters and convert it to milliliters. So with fractions, I want to put this on the denominator so that my units of liters can cancel out. Well, 1 liter is the same as 1,000 milliliters. Okay? I can do that because 1 liter is the same as 1,000 milliliters. It's the same like if we were to multiply 5 over 5. 1,000 milliliters over 1 liter, those are the same thing. But I set it up so that I can get rid of those units. And then I can just multiply. 2 times 1,000, which is 2,000 milliliters. I show you this because as we get into harder and harder conversions, it can be tough to tell, well, do I multiply in this case? Do I divide in this case? I'm not sure. So we set it up like this, and our fractions will tell us exactly what we need to do. So let's look at another example. The 5,000 meter run is an Olympic event. How many kilometers are in 5,000 meters? So we are given the information of 5,000 meters. So I'm going to put that over 1. And my goal is to figure out how many kilometers I have. So we know from that chart that there are 1,000 meters in 1 kilometer. The question is, where do I put that information? Well, I always want to put the units that I want to get rid of across from each other, or diagonal from each other, I should say, with your fractions so that we can cancel them out. So I would put meters on the bottom and kilometers on the top. And like we said, 1 kilometer is the same as 1,000 meters. So this tells me that I can get rid of my meters, and then I just need to divide 5,000 divided by 1,000, because that's what my fraction tells me. And I get that I have 5 kilometers. Okay? Let's try one more example of this. Okay? How about, let's look at a room is 15 feet long and 12 feet wide. what are the length and the width of the room in yards. So let's look at that 15 feet long. We are given that information, 15 feet. We put it over 1, and then we are going to multiply by something that is equivalent top and bottom. Well, if we're talking about feet and yards, 1 yard is the same as 3 feet. And if I want to get rid of that feet unit, I'm going to put it on the denominator and put the yards at the top, because that's what I'm trying to get to. And we say 1 yard is the same as 3 feet. Well, if we can't see this right away, all you really need to do is multiply across the numerators, so we get 15 yards, multiply across the denominators to get 3, and we see we just need to simplify. 15 divided by 3 is 5 yards. Okay, and we can do the same with my 12 feet. 12 feet over 1, multiply by 1 yard over 3 feet. The feet will go away, and I get that I need to do 12 divided by 3, which is 4, and my units now is yards. Okay? All of our unit conversion questions can be done using this method, and I would highly encourage it. Well, I hope this was helpful for homework and for your studying.